All right, good morning, everyone. I do ask if you're following online that you do turn on your camera. So today my goal is that we finish the soil electric conductivity exercise. And I hope that we're gonna have a moment to talk about the midterm exam as well. I want to share with you some insights I got from that. All right, so to begin with, let's work on the soil EC. So I want to ask you to, if you don't have yet, go ahead and launch that project so we see our project, so we can keep working on that. So last time we basically finished, let's see, I think we actually finished on the plotting it all together, perhaps. Yeah, so we finished creating the plots and exporting them. So if you want to come to so on your outline, if you want to come to the grid extraction chunk and just run all above, you should already have the code for all that to work. So on my side, I think it just, hope it went through. Oh, I actually had an error. So on my side, I had an error. If that's your case as well, then your chunk stopped running.
Yeah, I was gonna say right there, I didn't have those chunks filled in.
Yeah, that's right. I guess I didn't have either. So I was jumping ahead of myself. So we actually, if you were to go, yeah, so here on the interpolation, under interpolation, if you come under ECA 90, that's where we stopped actually. So we should be able to run everything above that, which is basically where we interpolated and created the map for the ECA 30. So the soil, the shallow electric conductivity interpolation and map as well. All right, so if you run all above there, you're gonna have all the objects that we created last time. And so now let's redo those same steps that we did for the shallow, but for the deep ECA. So the immediate next chunk here is where we're going to do the interpolation. So, okay, so here, let's talk about this, because this was one of the questions of the exam. And some of you got it right, some of you did not. So let's just think through that here. So for doing interpolation, regardless of the method, we're gonna have at least two steps. In this case here, we're doing inverse distance weighted. That's what we've been doing for the whole semester when we needed to interpolate. And for this, we have two functions that we need to use. So this is a two-step process where the first step here, we're going to define the formula and the data that variable that we want to interpolate is coming from. And the second part of that is where we actually predict based on the grid, right? So if you recall from the previous class, we already defined our grid up here. It has to be a raster. So it is in a raster format. This is our grid, and this is what we're going to be interpolating over, right? We already did that for the ECA 30. Now let's do for ECA 90, so the deep ECA. So can someone here help me to remember what is the function we need to set up the formula for the interpolation? GStat, right? So let's go ahead and start typing it. So GStat, it has this argument called formula. So here's where we define what we want to interpolate. I just want to print here, so the data set name is ECA_W. I just want to print that below so we can take a look at the columns. So we have already interpolated ECA 30. Now we want to go ahead and do the ECA 90_DSM. So the way that we specify that in the formula is just given the name of the variable that we want to interpolate and then say ~1. So that's all it takes. Then we give it a comma and we need to specify which data set this is coming from. So we say data equals to ECA_W. That's where our data lives. So if you run that, and now if you just print this object that we created, ECA90 IDW mod, this is just a formula model. So really no interpolation has happened yet. We're just setting up what is the column we want to interpolate, what is the data set name that's in. Now, the second step of this is to actually predict, right? And the function we need to use here is the function called predict. So let's just call that predict function here. So the first thing we give it is that formula object that we just created above. So ECA90 IDW mod. Give it a comma, and then we need to give the predicting grid, right? So in our case here, when we created the grid, we named it grid_r. So this is where the true interpolation happens, right? So it's going to take the data and is going to apply that to the grid that we already created. If you run that, you're going to see here this message, meaning that it's doing the interpolation. And if you print this object here, is going to be a stars object. Now, if you look into ECA IDW, I guess ECAW, so the data set where this is coming from, this is a SF, right? So it is a vector. So ECAW, the data where the variables is in, is a simple feature object. So it is an SF object, a vector type. The grid here is raster. So once we use the formula based on the data that was SF to predict on this raster grid, our output is actually a raster as well. It is a stars object, which is a raster object type. Where again, for each one of those cells in that on that empty grid, now we have a prediction of ECA90. I left you here all the code for that map because we have already developed this code once for the ECA30, so we're not going to do that again. But just very quickly here, we're starting to plot, bringing a geom stars because we want to plot the object above, which is raster. So it is a stars object. We need geom stars for that. We're changing the fill here to Virides. We're also adding as a geom SF, we're adding the boundary here, changing the label of the legend, and then applying our theme. So if you just run that and you print it, this is what you should get. And then lastly, I also left you the code here for plotting it all together. We are using the package Patchwork, which is what we use when we're willing to combine 2 or more ggplot objects. So this plus here is actually coming from Patchwork and not from ggplot. This is what we will get. So the ECA at the shallow and at the deep layer. And then we're exporting this using ggsave, just bringing that to our output folder. We should have a soil ECA right there at this point. All right, so here's something that I want to remind you. We've been doing this a lot, and I just want to remind you again. When we work with EO data, when we did the EO stability, spatial temporal stability classes, when we worked with the terrain variables, and now with the EC, I want to have all these layers as vector. So right now, our ECA interpolated variables are all raster. And I think if we have them as vector, it's a little bit easier for us to see as a data frame and to interpret that as vector. So I do want to transform that right now from stars to SF, from raster to vector, so we can then export this and then keep going with our exercise. We've done the same step here before already, so it should not be anything new to you. But the way that we want to do here, so first for the shallow depth, we're going to assign the result of that to this object called ECA_V. Let's just give it the assignment symbol. We're going to start off with the object that right now is as stars. So that is the one we created above for the interpolation, ECA30. Let's see, IDW pred. Yeah, so ECA30 IDW pred. If you want to print that below, you should see that is a stars object. So now for us to transform this here from raster to vector, we're gonna use the function, so give it a pipe, we're gonna use the function st underscore s underscore sf. So remember that this function here we used before, right? So we used this function here before when we had a CSV, and we bring that as a data frame, and we want to transform that CSV into an ASAP object if that CSV has the coordinates, 2 columns for the coordinates. In this case here, the coordinates are already implied on the stars object because that's already a geospatial file or a geospatial object. It's just not of type SF. So we're just bringing here, we have to change a couple of arguments here. So the first one is called s underscore points. We want to say false. The default here is true. And if you don't change this behavior here, what's going to do is it's going to give you the centroid of each raster cell as a point, and that's the data is going to give back to you. By setting it to false, like we're doing here, is actually going to transform each one of the raster cells into a small polygon. It's going to give us polygons back rather than points. Also, we want to say merge equals to false. So each cell, each small polygon that we get back has its own row in the data set, its own ID. So if we just run this and we print it, we see now it's a simple feature collection, which what we wanted, it's of type polygon, which is also what we wanted. If we had left s points equals to true, which was a default, this would have been point. So right now we're getting a polygon back or many polygons back. And we have that var1 pred and var1 var columns there. I do want to keep just the var1 pred, and I also want to rename it as I only keep it. So let's add a pipe here. And if you recall, to select a column and rename it as well, we can use the dplyr : select. And I just want to call, so the way that this works, if you remember, is we first give the new name if we're renaming, right? So if we're not renaming, we just give the name of the column. If we are selecting and renaming in the same step, we first need to give the name of the new column that I want it to be, and then equal sign the name of the current column. So I want to keep var1 pred, but I want to rename it to ECA30 underscore DSM. So this is the name of the new column, and then I say equals to the name of the current column, which is var1.pred. So we just say var1.pred, run it and print it. So now our SF object only has that column, and then of course has a geometry column, which is always going to be there for an SF object. All right. Once we do that for the 30, I left you the same code for the 90. The only differences here is that we're changing the data set coming in. Now it is the ECA 90, and we're also changing how we're renaming our variable here. So it's being renamed to ECA 90 underscore DSM. So make sure you run that. Now on the next step, I want to merge these two layers. Because I think it's going to be a little bit easier for us to export one ECA layer that has both depths in it rather than exporting them separately. So before we do the export, we have to merge those two layers. So the way that we're going to do that is by starting with the ECA 30V, which is the object we created above. So ECA 30 underscore V. And then we're going to merge them. Anyone remembers what function we've been using here to merge two data sets?
Join.
ST join, right? So ST underscore join. And just a reminder here, if your objects that you're merging are geospatial, so they have already that geospatial component intrinsic to them, then we can use ST join. Sometimes if our objects are not geospatial, they're just data frames, we use left join, which is applied to any data frame. In this case here, our data frames or our objects are geospatial, so ST join is what we need. So the first thing here is we're going to give what other object we are joining. So that's the ECA 90 underscore V. Let's give it a comma. So if I'm just gonna ask for help of this function very quickly here so we can take a look at the arguments. So help st join. So if we come to the arguments, here there is an argument called join. We talked about this before. I just want to remind you. So the join that is the default here, I believe is using the function st intersects. However, for our case, that does not give us the proper number of rows that we wish that we would get. So when I was going through this exercise the first time, I played around with a whole bunch of functions. So we have here st intersects, disjoint, touches, crosses, within, contains properly, overlaps, equals, covers, cover by. There's a whole list of types of joins you can make. And I'm showing you this because the default in our case did not work. So I went through these, I read through the different ones, tried a few ones until I got what we needed. And what we needed turned out to be, so if you change the join arguments, what we needed is the st underscore equals. You don't need you can just leave just the words, you can remove the parentheses there. And then lastly, there's an argument called, if we left, we need to say left equals true. So this does a left join. What does that mean to do a left join? In this case here, maybe it wouldn't really matter, but a left join is basically, so right now we're bringing, the first thing we're given is ECA 30, and then we're giving ECA 90. The first thing you give is considered the one on the left. The second thing you give is the one on the right. So if they don't have the same number of rows, then a left join is going to look into the data set of the left and is going to merge, bring over the one on the right, but the final product should have the same number of rows as on the left. We saw this when we were doing the terrain variables. If you remember, elevation, so elevation had the most number of rows, and then when we did slope and aspect, we could not calculate slope and aspect near the border of the field because you need all neighboring cells to do that. So all the slope and aspect objects, we have NAs near the border, meaning they had less number of rows than elevation. If you don't remember this, you can go back to that exercise and run again those chunks, you're gonna realize that. So in that case, it was really important for us to have elevation as the left one and do a left join, because then when we brought slope and aspect, all the cells on elevation that had data, but did not have data on aspect and slope, were just assigned NAs for those variables of slope and aspect, but still kept the variable for elevation there. This makes a difference sometimes. So if you run this and you print it, I just want to also remind you here, every time you do a join, it could be a spatial join like we're doing here with st join. It could be just a non-spatial join, which is when we use the left join function. You do want to check that the final number of rows is what you would expect, right? So if I'm starting here, ECA 30 has, in my case, 4,046 rows. ECA 90, if I print just that by itself, has the same number of rows. And so if I merge them, if I join them, I should end up with the same number of 4,046 rows on my side. On yours, you may have a different one because of the boundary that we did separately. But so I check on that. My final product, ECA V for vector, does have 4,046 rows. So we check that that's correct. I do want to show you here, if I just comment off the join equal st equals, it's going to do an st, it's going to use the function st intersects to do the join. Let's see if that would give us the correct number of rows. It does not, right? So it gives us 35,000 rows where we should have 4,000 in my case, 4,000 something. So here's, just to illustrate again, the join that's doing by default is not what we want. It should be st equals, and always make sure you check the number of rows after you do any type of join to make sure that it is what you would expect. All right. Now the last thing here is just really to export this file here, so we have it on file and we can bring all those process data that we've been working with and bring them in to do zones, right? So if we're going to export this, we're gonna save this to file, and we want to export this object here, right? So ECAV. What function do we need here to do that? Okay, so Ujjwal said write underscore SF.
Right, SF.
Yes, and that's what we want here because the object we're exporting is an SF object, right? So it is a simple feature object. If this would have been a raster of type stars, we would use write underscore stars. If this would have been just a data frame, it could be write CSV, it could be write Excel if you call the package that has the function, and so on. So let's go ahead and call write underscore SF. The name of the object is the one we created above, ECA underscore V. If you break line, add a comma and break line just so we can see better. Open and close quotation marks. We want to get outside of the code folder, so .. /. If you hit tab, I want to go inside of the data folder. And here's where we give both the name and the extension. I want to call this ECA underscore V .geojson. And lastly, we want to add one argument here. So give it a comma, and we want to change the name of the argument is called delete underscore DSN equals to true. Again, the reason why we do this is if you don't change this argument, the default is false equals to false. And in that case, each time you run this function, it's going to append your final object or your final file rather than overwrite. What that means is the first time you run it, your GeoJSON is going to have, in my case, 4,046 rows. The second time I run this, it's going to have 8,000 and so on. So we don't want that to happen. We don't want to duplicate each time you run it. We want to overwrite in case you do have to run this twice. So we do that delete DSN. Once you run this, go on your files tab, go on the main folder of this project, go under data. You should see your ECA underscore V .geojson right there. All right, so let's go through a quick summary of what we did through these exercises of the soil electric conductivity. So we imported the point vector soil electric conductivity apparent data, right? So this would be the data set that you would get out of a Varius, for example, which is one of the equipment that collects this type of data. We then interpolated the soil EC at 2 different depths as we get those 2 different depths already from Varius. And we interpolated that using the same grid as we used before, right? So when we use for yield and for terrain variables, we're all using the same grid here with the intention that at some point, which is going to be the next exercise, we're going to bring all these layers and we're going to play around with them in a way that we want them all to have the same extent and also that the cells are all matching throughout the different layers. That's why we're interpolating them with the same grid. And then lastly, we transform them into a vector. So the interpolation product is a raster type of object, is a stars object. We transform that from stars to SF, so from raster to vector, and then join both of the depths in one object and export it to file. So now we basically got to the point where we process all the data that we had for this field, and we're ready for start creating management zones, and also we start validating the zones that we're creating. So really the next step is going to be to do those 2 things. Let's say if this is your field and you have other layers, maybe you have gridded soil samples that you collected, or maybe you have collected something else on this field that is georeferenced. So perhaps, you went out and collected aflatoxin contamination on peanuts that you have geospatially tagged. Maybe you want to do some of these steps with that as well, depending on your sampling density. Or whatever it is that you may be sampling, and you have a location of that sample on the field, and you want to bring that in a similar workflow here, you would just keep doing. If you pay attention to this, we've been basically doing the same steps of bringing data, interpolating, and then exporting for the last couple of exercises. So this is just that workflow that you would do for any other layer that you have. All right, so this basically wraps up this exercise here. We have a moment here to talk about the exam. So I saved this script. I'm gonna close this, and I wanna show you some takeaways from the midterm that I got from my side. All right, so just before the class started, I went ahead on your ELC, and under the midterm, I did not yet write the full grade that you got, but I gave you feedback on that midterm, which is basically my feedback there. It's just, I guess, 2 rows and many columns, where the first row of the feedback is going to be your overall grade for the midterm. So you can check that. It's going to be under a column called total. And then your individual grades for each one of the questions that we had, on a scale from 0 to 100 on each one of the questions. The way that I graded this, so the exam had 18 questions. Each one of them was worth 100%. So your final exam grade is basically just the average across all of those questions. And again, if you go on your ELC right now, on the feedback of the midterm, you should be seeing your grade, your total grade, so the average of all 18 questions, but also your question-specific grade. So if you want to check that out now.
So total, the little number to the right of total right there, that's our individual grade.
Yeah, so if you look on the feedback, are you seeing like,
I see like total Q1, Q2.
can you open that?
I can't open it,
You
but it
can't?
shows it all.
Let me see on Ujwal's, who's closer to me here, just to make sure that you can see what I hope that you can see. Yeah, so I think it is like, so we have the column and it is right, just right adjusted. Yeah, so the first number on that second row, it would be your total. Yeah. Yeah, so I guess on your side is not quite aligned, but the first number that you see there should be your grade, overall grade for the exam, and then you can see the remaining other questions as you move forward. So it is right adjusted, I guess, but it still should still match the same columns. So the way that I graded this is that most of the questions had different parts of them. So I don't think really there was any other questions that you answered had like, it was either you got everything or nothing. Most of them were broken down into 4 to 6 different points that you could get. So whenever you were giving me an answer that was partially correct, based on what I was expecting for that question and the answer for that, you would get partial points. I guess people only got 0 either if you miss all the points inside of the question or if you left it blank, but otherwise, at least you got some partial for most of them. I noticed that there were some questions that were only partially answered. So I do want to point that out, that some questions had like 2 parts, 2 questions inside of the same one. So if you answer only the first part but not the second, then I cannot really give you a grade for that second part of the question. So just yeah, like I would say, pay more attention to the actual question as you're answering. And the overall mean was 74.3. I do want to show you here a little bit of the distribution of that. So this is the distribution of the exam. I don't think anyone got 100. A handful of people here were above 90. And then, so we range from about 95, I think, 96 to 34, I believe, was the lowest. This is the distribution overall. And this was a distribution of grades for each one of the questions, where again, each question was worth 100%, so they all had the same weight. And then this is the average across all of you for each one of these questions. So we see that there were some questions that a lot of people missed them. So question 10 seems to be a tougher one, question 11 as well. And then there were some that were really higher up. So 17, 18, question 1 as well. So this is just to give you an idea of that distribution. And this is the distribution of grades for each one of the questions. So we see like question 1, most people got 100. So 100 here on the x-axis was the highest. And then other questions were more variable, right? So we see like question 10 being a lot of low grades here in this density, and so on. All right, so here's what I want to tell you that how we're going to move forward with this. If you're interested in improving your grade, next class, we're going to take the first hour of the class to do a midterm follow-up. What is that going to be? I'm basically going to give you now a QMD script with these questions, a little bit different. I'm going to introduce them better on Wednesday. Some of them, especially the coding questions now, I will give you that script. I will give you the data sets you need. On the coding questions, if you want to make up for them, you're going to actually have to code from zero. So I'm not going to give you the scaffolding as you had on the written. You're going to have to do that based only on what I'm giving you as instructions. But for all the other questions that are more theoretical, you're going to have a chance again to go back to them, see which ones you missed, and then try one more time. It's going to be in class, so it's not going to be an assignment to take home. It's going to be in class. You're going to have 50 minutes. You can use your material in class. You can use your codes, you can use your notes, if the lecture, whatever it is, you can use all that. Because my goal is for you to recap and see what you missed and have another chance of learning this and answering again. What I'm going to do then is, so in the midterm, on the written part, I was giving you, as I was telling you, questions had multiple points within the question that you could earn. And so, if you did not answer everything correctly, but you answered parts of that, you got partial points for it. In the midterm follow-up, it's not going to be like that. You either get 100% correct or you're going to get a 0. And then in the end, if the grade for a given question that you got on the midterm follow-up, which is going to be next Wednesday, is higher than your current grade, that gets updated. If the grade you get on a given question on the follow-up is lower than your current grade, then you just keep your current grade. So that's how we're going to do next class. You will need your computer because this is going to be a QMD that I will share with you. You're going to answer on your side. You're going to render that to HTML and send me the HTML of that. And again, on the coding questions, I will give you the data set that you need to create the code to answer those. And so you're going to actually have to code from 0 without a scaffold like you had on the written. And again, that's going to be this Wednesday, right? So next class. And we're going to use the first hour for this. So we're not going to have a full 2 hours. It's just going to be the first hour of the class for you to do this in a chance that you're going to have to improve your grade. If you don't want to do it, if you don't care about improving your grade, you don't have to do it. It's not mandatory, but it's going to be one chance that you're going to have to do this. And again, you're going to be able to use your material for this. It is going to be individual, so you're not going to be allowed to share answers or talk with your colleagues. It's going to be an individual in-class assignment. Yeah, and I guess that's all I had to tell you about that. Any questions? Maybe about the SOIC or maybe about the midterm or what we're going to do next Wednesday. Yeah, so Renelisa asked if it's still going to be 18 questions. Yes, it's still going to be the same questions as you had On the midterm, the only difference again is that the coding questions are gonna be, because since now we're gonna have the actual data and the actual scripts in your computer, the coding questions, you're actually gonna have to do the coding yourself, as opposed to the written where you had a scaffold to begin with.
So really, we can just go through that and like look at the questions that we missed points on and just do those questions.
Yeah.
Don't have to do it.
Yeah, so Doug here is asking like, so you're just gonna go, yeah, so the reason why I gave you the feedback that I gave right now is so you can look at each one of the individual questions and see where you miss points. So if you got 100% in a given question already, you don't have to worry about that. You're just gonna write 100% as your answer and move on to the next one. Any questions you got less than 100%, then you're gonna have a chance to try again. And again, as a reminder that I just mentioned is, on the midterm, you were getting partial points for a question. On the midterm follow-up, you're only gonna get the question if you get 100% right, right? If you, again, get other parts wrong, maybe, and get other parts correctly, for a partial point, that's not gonna count on the midterm follow-up. So you're just gonna keep, in case you try a question that you had, let's say 50% correct, you try that again and you get 66% on that, you're not gonna improve that grade. You just improve if you get 100% of the question correct now in the follow-up.
I have one question.
Mhm.
Although it's not exactly, I think you can answer right now, but in question one, I saw the graph for entire class, it was around 94.3. And from what I remember, first question was match the following. And I am not sure if I did that wrong. I feel like it was totally right, but the whole class did it wrong. So I just wanted to ask, what is there anything that, I mean, the question was totally right to, not miss it or something.
No, so on question one, for example, you had 6 blank spaces to match, right? So let's say, I guess most people got all 6 correct, but people that miss, the most common miss would be like you flipped one of, right? So let's say, what was the package for SF and over? What was the package for vector? What was the package for raster? If you flip those, then you got 4 out of 6. Right, because you missed 2 of those options.
Oh, I see.
Yeah.
Okay.
Any other question?
I have a question.
Yes, go ahead.
I really love this opportunity, but I have an in-service training, so it's part of my job on Wednesday, that it goes for 6 hours. And I know that I've missed a lot of the classes for work, but I wanted to see if there's another options for me.
Let's talk individually about that, Rolando. If you can send me an email, we can discuss that.
Okay.
All right. Any other questions? Okay, I don't hear anything, so let me get you all attendance for today, and then we're gonna wrap up a little bit earlier. All right, so just open up the issue for attendance for today. Make sure you claim your attendance. And then, yeah, if you don't have any other questions, then you're dismissed for today. Remember, again, next Wednesday, the first hour is when we're gonna do this midterm follow-up. And again, it's gonna be open book and individual, right? So no working with your colleagues, but you can use your own material to answer the questions. And bring your computer as you would normally, as that's going to be done through a QMD file. All right, if you don't have any more questions, then we are done.
I'll be asking the same question. I think for my first number question, I would like you to check my grades once again, because I believe if I have missed it, so I would have corrected 4 out of 6. In that case, my grades will be relatively lower, because what I'm saying, it is 94.3. And if I'm doing my calculations in my head, I don't think if I missed 2, I will get 94.3. I would get significantly less than that, or otherwise I will be getting 100. I don't know. Just keep an eye out on it once more.
You can send me an email, we can
Okay.
connect by Zoom and I can show you more closely your own grade. Yeah,
Okay.
we don't want to talk about individual grades
Sure.
in front of everyone.
Yeah. Sure.
Yeah, but we can connect
Thank
and
you.
go through that.
Okay. Sure.
All right. I think that's a wrap up then. Thanks everyone. See you on Wednesday.